Saxon Algebra 2, Lesson 12. Look, you guys, it's a single topic, and we're going to talk about the equation of a line. We covered this extensively in Algebra 1, but here's the thing, you guys. When most people think about high school algebra and what a student is expected to know who has conquered high school algebra, this is one of the main topics. I'd say this and systems of equations are right at the top of the list of, oh, so you think you know algebra, huh? So that's why we go over it, and really just build that into the bedrock of your mind. Remember that the equation of a line that we are most interested in looks like this, right? This is called the slope-intercept form. There are other ways that we can write the equation of a line, but we like this form where y is here and x is here because it makes it super easy to graph. What it identifies for us are two important numbers, and I'm going to talk about this one first because when we graph, we want to locate this number first. John's giving us some really easy information. Okay, B is called the y-intercept. It's the place intercept. This is the place where our line crosses the y-axis. Okay? Easy. This is the slope. This tells us how much the line tips in either direction. If the slope is a positive number, we think of it as the rise over the run. And remember, the way we graph this is we go to the y-intercept first, and then we use the slope like a treasure map. If it's a positive slope, we go up a number of steps, whatever's in the numerator, and then we go to the right, the number of steps that are in the denominator. If it's a negative slope, we don't rise, we sink. We go down first. Right? If our slope is not in a fraction form, we can always put it over 1. Okay? So this is always a fraction. This brings to mind this fabulous picture that is one of my favorite it's my favorite illustration in the whole book. Although sadly yours, this one is a lesser version. When we have a positive slope, we can imagine that our lines are little hills, and we have cars riding up the hill. They're going uphill on a positive slope. I think it's the Algebra 1 book that has not just an empty car, but a little person, a woman, I presume, with a ponytail, a sassy little bouncy ponytail that is sticking out. And I just love to, it's a convertible, right? She's got a rag top down, and she's just cruising up those lines, and her slopes are positive and her ponytail's bouncing. And then when we have a negative slope, it's like riding downhill. And, you know, I imagine her ponytail blowing out in the wind because some of these get pretty darn steep, right? When you drive on mountain grades and they say 6% is a really steep grade, I always think of the lady in a ponytail going screaming down some of these really steep slopes. So, fun fact, slopes are actually cars driven by women in convertibles with ponytails. But positive goes uphill and negative goes downhill. All right, so we have this information, and we did a lot of stuff last year with this whole equation of a line business, but we're going to start right now with John giving us pictures and us figuring out the equations of the line. I don't like these problems because sometimes it's hard to see where the line crosses at an exact number. But let me just show you the picture. Okay, so, and this is the only problem for this lesson. We're done in a hot minute. All right. This is really hard to see. This is line A going up and down. This is line B going horizontally here. And this, the only line that is actually a little hill going up or down, is C. I want to start with C because it's easier to It's the kind of line we see most of the time. This straight vertical and straight horizontal, those are kind of freak children. We're gonna get to them, but I wanna do just a nice normal one first. So we go to the place where our line crosses the y-axis and it's right there. So we know that our y-intercept equals 3. So I'm gonna write that down. B equals 3. And this is for line C, because there's A, B, C to this one. Now we have to figure out what the slope is. So we see that it's going uphill, it must be positive. Here's another really clear point that we can use. So we can see that the secret to getting from here to there is go up 1 and over 3. Okay, so let's take that back here. Up 1 and over 3. So our slope must be equal to 1 over 3. Now we've got the information and we can write our line y equals 1/3 x plus 3. And what that means is that on this line, any point for x that we can choose, right? All of these infinite numbers, number of numbers going to the ends of the universe in either direction, fractions, decimals, any tiny little thing we want to do. If we plug in any one of these x values to this equation, we'll get a y value, and that x and y pair will lie right on that line. Okay? That's cool. I'm just going to draw quickly the rest of the graph because I want to be able to talk about it without having the book in the way. This was line A. And I'll do this one in blue so it's easier to see. And this is, okay, so this, let me do this in orange, because right now it's hard to tell which are the lines and which is the original graph. Okay, this is the original graph. And I'll leave that without arrowheads so we can tell. Okay. We know that both horizontal and vertical lines are kind of like freak children. They're a little weird, and so we have to have a special way of thinking about them and dealing with them, because this whole rise over run, that's too confusing. So what we do is we look at, let's start with A. On line A, if you think of all the points here, every single one of them is going to have an x value of -3. So that's the equation of the line. X equals -3. No matter what you choose for y, x is equal to -3 no matter what. So that's the equation of this line. This is a vertical line, and B is the horizontal line. Let's look at that one. With B, this is y equals -4. What that means is that no matter what value we have for x, y is always equal to -4. So that gives us a horizontal line. So the rule of thumb that you don't even have to memorize but is true is that when we have a vertical line, our equation will be x only. When we have a horizontal line, I spelled that wrong, horizontal. Drama. When we have a horizontal line, it will be y only. All right? So these two are the anomalies, but they're pretty easy to figure out. Just if you see that the line is perfectly straight in one direction or the other, just think about it and logic it out and know that it's just going to be one letter. It's not going to be really this form. Technically it is, but I don't want to talk about that. All right, that is our lesson. Let me just show you in the homework. Line A is really hard to see. It's this one here. It's just a tiny bit darker in my book than the grid, so it's hard to see, but that's A. And then B. Oh, that little ponytail is going to be screaming downhill, isn't it? Okay, so your job is to write those lessons. Remember that I'd like you to do all of the practice problems and then just the odds of the problem set from here on out. But I do like you to do all of the practice problems because there usually aren't that many. So, okay, lesson 12 is history. Thank you. Goodbye.